Hi there. I received my first video or email request for naming hydrocarbons, and so I'm going to go through a very quick way on naming these things. Um, First off, you have to identify how long the chain is, and I've got some rules set up on the next slide, but we'll look here that first of all, when you're counting them, if you see a one carbon chain, which isn't much of a chain, mind you, it would be a methane. If there were two, the name you have to remember is ethane, 3 for propane, 4 butane, pentane for 5, 6 for hexane, 7 heptane, 8 octane, 9 nonane. So you would be counting how many you have. And so the base, or what we call the parent chain, the length of it, I'm going to be using those words often. And it's something you find all over the place, and most chemistry textbooks will have that table there for you. Moving on to things that are attached to it, when we have things attached to it, you're going to be throwing in some extra words. If a chlorine is attached, you're going to call it a chloroethane, for example. Or if bromine is attached, you'd add the word bromo onto the front. Methyl for methane, and ethyl, if it has an ethane attached, propyl, propane, I think we see a pattern, right? So these functional groups or extra things that are added on are would have a name, and you give it a number based on where it is. Anyway, you'll see when we do some examples here. So we'll keep flying along. So our steps are to identify. Step 1, identify the longest continuous chain in the carbon atoms, which we'll call the parent chain, and we'll number them starting from the end closest to the branches, or the end closest to where any double bonds would occur as well. Step 2 is to identify the branches and their location on the parent chain. So what the branch is, so any branches and their location, what and where. Then we're going to write the complete IUPAC name following the format of the number of where it is, what the name of the branch is, and then the parent chain. And we'll change it up as we go along. I'm trying to do an abbreviated version of this. So when we're figuring out it, because there will be multiple branches, if you have to put 2 or 3 branch names down, you'd put them in alphabetical order, meaning you would write ethyl before methyl to put them in that proper order. So we might as well just jump in and throw something at us here. We're going to look at this particular chain, and we want to come up with a name for this guy. So we have to identify the longest chain, and we can number it in a number of different ways. You could start numbering from here, 1, 2, 3, 4, 5, 6. That would work just fine. Or we could start numbering 1, 2, 3, 4, 5, 6, as long as we have 6 chains and recognize that no matter how we count it, we're not going to get more than 6 chains, or 6 carbons in the chain. 1, 2, 3, 4, 5, 6. All are different ways. So you want to count it where you can count the branches coming off quicker to one end. That means we wouldn't want to have 1, 2, 3 from here, because then you'd have a chain on 4 and 5. You'd have a 2 carbon chain attached to it and a 1 carbon chain. These 2 functional groups are at the other end. So you want to make the numbers as small as possible. So we would start, I think it's reasonable to start out at this end. 1, 2, 3, 4, 5, 6. So it's a 6 carbon chain. So our parent chain for 6 is a hexane. Now, if I saw a double bond in here somewhere, I would call it a hexene. Or if I saw a triple bond, I would call it a hexyne. And since I don't see any of those, I'll stick with hexane. Now we look at what branches we have attached. I have a 2 carbon chain attached. A 2 carbon chain is an ethane if it was just 2 carbons, so that is an ethyl group, because ethane was ethyl as a functional group. The ethyl group is on carbon 3. We have a methyl group, 1 carbon chain, so it's a methane, which becomes methyl, and we have a methyl group on carbon 2. So when we want to list all those off, we want to list what they are and where they are. So we put them in alphabetical order, E before M. So we have a 3-ethyl, 2-methyl hexane. And it's as simple as that, but of course it gets more and more complicated. So we'll throw in a double bonded critter and see how this works. Now we start counting. 1, 2, 3, 4, 5. It's a 5-carbon chain where the double bond is in between 2 and 3, or at the second carbon. This is why we would not number it from this end, 1, 2, 3, 4, 5, because the double bond would be at the third, and you want to use it in the smallest way possible. So 1, 2, 3, 4, and 5, and you ensure that the double bond is indeed in your chain. So a 5-carbon chain, having 5 of them, is a pentane, but the fact that it has a double bond in there means we will call it a pentene, E-N-E. And recall I said if it was a triple bond, it would be an Y-N-E, a pentyne. So this is a pentene chain, and it's on the second carbon, so it is a 2-pentene, because you want to tell where that double bond is. Now, the only functional group I have on here is a methane. So it is a methyl pentene, and I have that attached at the third chain. So it's a 3-methyl-2-pentene. Now we count our chain, and it doesn't really matter how we count this one. I'll count it this way just to vary it up. 1, 2, 3, 4. So I have a 4-carbon chain, methyl, ethyl, propyl, butyl, so we're dealing with a butane. But wait a second, it's not a butane. It has a double bond, so it's a butene. Okay, now the double bond isn't on the first carbon, it's on the second. So it's a 2-butene. And on the second carbon I have 1 methyl, and on the third carbon I have another methyl. So because I have 2 methyls, we are going to write that as a dimethyl rather than writing methyl twice. So we have a dimethyl. We'll erase that and squeeze it in here. A dimethyl 2-butene, but since we have the dimethyl, we will write the 2 places where they are, i.e. a branch off of carbon 2 and off of carbon 3. So you have a 2,3-dimethyl 2-butene. Now the question I was specifically asked about is, if I can drag it down here where we can see it, would probably have looked something like this, although that is kind of messy. But if I was naming this guy, again, you start from the end where your carbon, the double bond, is closest. So we have a 1, 2, 3, 4, 5. So I see that it's a 5-carbon chain. It's a pentane, but a double bond makes it a pentene. So we've got our pentene on here, and we need to note that it was on the second carbon, so it's a 2-pentene. And off of this pentene, we have a methyl group, or methane. So we have a methyl group off of the 2-pentene, and it's on the 4th carbon. So you can have very complicated ones as we move along. You could have them in a ring, so it could be a cyclopentene, and there's other numbers, but for a very quick, basic, how do you get started, that is a fast way to look at it for now.